We could work this out a different way, though. Do we necessarily have to choose a path that goes directly from A to B or A to C? What other path could we choose? Okay, why don't we go from A to B and then B to C, all right? So we go from A to B. Let me erase some of this here. If I go from A to B, then what's my path vector? X is 5, y is 0, z is 0, okay? So I have delta V going from A to B. We have a negative, I have negative 200 times 5, and then 400 times 0 and 0 times 0, so I'm just going to get positive 1,000 volts. But if I go from B to C, what's delta L for that path? What's the x component? 0. Y component is negative 2, 0. Field is the same. So when we go from B to C now, we have negative of, well, is the negative 200 going to contribute at all here? Negative 200 times 0 gives me 0, plus negative 400 times negative 2, plus 0. I get negative 800, right? And then I can just add the two up and say that the total is when I go from A to B and then B to C. Gives me 1,000 minus 800 or plus 200. And you can kind of even see that coming out of the math here. You have 1,000 here and 800 here from just adding those two components together. I haven't proved this. It works out, but I haven't formally proved it. But this is a useful property that's called path independence. Delta V's are independent of path. Independent of path. As long as the initial point and the final point are the same, you can choose any path you want, and you've got to get the same result. Okay, I haven't formally proved that, but it works out that way, and it's a very useful result. Another way we can write this, if I say delta V from A to C. Now, as the delta indicates, it's a subtraction. It's a final minus initial. I can say V sub C minus V sub A. Well, this implies that there is a value for the potential at a location C and a value for the potential at a location A. How we calculate that is a different story, and we'll deal with that later in the next lecture. But there is a particular value at the potential. We're finding the difference between them. So if I add these two pieces together, I can say VB minus VA plus VC minus VB. VB will cancel out. We have positive and negative. And I have VC and a negative VA here, so I get back VC minus VA. Okay, so that tends to suggest that, again, you can do this adding up of the paths and get the same result.